Good morning. How's everybody doing this morning? Back down here in the bunker again, here in Knox Vegas. Today's going to be a pretty cool one. We've been talking about the 6S meter and some of the things, the capabilities of the Powermetrix test kit as far as pre-test, looking at some of these vectors and looking at things and making comparisons. And once again, using these and this to realize if we have issues or not. And because we always preach that, take a look at the vectors and take a look at the, some of the power charts and everything. Looking at those first, and it can detect some issues you might have. So it really comes into play here when you're talking about a 6S. And so before we get rolling, I'm going to go ahead and pray us out, and then we'll get into it. Father, I just want to say thank you this morning. In the midst of everything that's going on, I ask that we just we remember that we've put our faith in things unseen. And so right now we're putting our faith in you. And I know it seems in the midst of all the turmoil and things that are going on right now, and people just unfortunately using people's misery for politics and everything we see going on, it's just not a good thing. And it can put us in a bad mood and kind of bring us down some to see how people are reacting to the things that are going on in this country. But just like the disciples in the boat, when the storm came up, he calmed the sea, and then he looked at me and he says, well, where's your faith? So, Father, I hope we'll have faith as Christians. I hope we'll have faith as a country, and remember that you're in control of everything. And that no matter what, it may not be now, but one day we will see that everything's been done for a reason, and everything's been handled perfectly because you are perfect and you are God. So, all these things I ask and say according to the will of the one who paid it all, my brother, Jesus Christ. Amen. All right, let's roll. So we will go through, let me go through these slides first. Today is troubleshooting a 4-wire Y. It is a 6S meter with a Z coil. So that's what we'll be talking about today. So just real quick, we're going to show this wiring diagram. This is a 4-wire Y Z coil. You may recognize this screen that comes up on the Powermetrix test kit prior to any of the tests, before you test the meter, the PTs or the CTs. This will come up just to show you where to make your connections, but it also gives you an idea of what's going on and the connections that are made for the particular service or meter form you're using. You'll notice here, you're typically going to see 3 for a Y, right? For a 4-wire Y, you're going to see 3 voltages and 3 currents. So you would expect to see 3 voltage connections there, but notice the funny looking things up there towards the upper left on the actual diagram. We're actually only using 2 voltages now instead of 3. Okay, so that's where the 6S with the Z coil gets kind of funky, is because we're only utilizing 2 voltages instead of 3. So when they do that, it definitely affects us on the vectors, how the vectors look. So you have to remember, use those 2 eyes in your head and think about it a little bit. But there are also the capabilities of the equipment to toggle between some screens, so we can look at that, between looking at the power, looking at the different vectors, a connect view versus meter view. So we're going to go through all that today as we're going through this. All right? Okay. Now, the very first thing, so I guess we're live on there now? Okay. So the very first thing I want to talk about is an email, a mass email that went out that said, why are you ignoring me? That was not me. That was Jarrett, Mr. Marketing. So Jarrett, who is now coming out from behind the table, this is what Jarrett is going to say. Jarrett is going to say that it worked. And it did, except for one thing. They all come back to John. So all this goes out as John Jones. So my phone has blown up, my email has blown up, and everybody's going, I'm not ignoring you, John. So that was a bit of a surprise. They didn't let me know about that one. So I owe them one, so they got that one on me. So that was pretty good. So yeah, guys that owed me phone calls were calling me and going, I wasn't trying to ignore you, man. I've just been really busy. So that wasn't me. I don't think any of you are ignoring me. Well, maybe a couple of you are, and I wouldn't blame you really. But I didn't send that out. So ease up on some of these responses, okay? I'm not telling you you're ignoring me, all right? Okay. So we're talking about here we have, this for us on the bench is a dual socket, okay? We can run a 9S or a 6S on here, okay? So when we get ready to get in here, I just want to show you guys something, because someone's going to send it on the chat room and go, hey, Wade, you got the connected. No. For us to be able to toggle between the 6S and the 9S, you'll notice right here my blue is typically my C phase for any of the Powermetrix equipment, right? Red, yellow, blue. So you'll notice my blue voltage connection right there is actually on my B phase as far as this test switch voltage. But that's when we toggle between the two, when we go to a 6S, that's where we're actually picking up C phase, is actually what would be designated as the B phase switch, okay? So before you guys start ripping me on the chat room, that's why it's connected the way it is, okay? Because so far, I will say this, the guys in the chat room pick up a lot of things. They've been pretty good at noticing things. So I'm just letting you know right now, that's why that is the way it is, okay? So what I'm going to do is, I'll go over the connections here real quick. With a 6S Z-coil, I still am using 3 CTs. So I have all 3 of my red flexes are in here, right? So I've got all 3 of them. I've got, so you can see here, all 3 of the CTs are lit up. This is, of course, my can's lit up right here, and we're going to utilize the 6S service on it. Okay, so my connections are, I'm right here on my A and C voltages, okay? We don't have any B here, right? Because remember, we're only using 2 voltages here. And then I've got all 3 of my duct bills are in right here, okay? And then, of course, my neutral's connected there. Got my pickup right here to pick that up. Now let's go up here to the PTs. And here at the PTs, I'm on, again, A and C on my PTs, all right? Oop. I'm on A and C on my PTs. You can see right here. And since my neutral's tied together right here, my returns, went ahead and tied my return right there on A phase for my white alligator clip. So again, just A and C, we only have 2 voltages with this Z-coil. All right? So let's go ahead and we will run, I think, Chris, first we're going to run a normal test, right? Can you all hear Chris, by the way? Okay, you can't hear Chris? Okay. We'll make him come get on camera when he talks, because he doesn't really like that, so we'll make him get on camera. Okay, so let's go ahead and we'll just run a normal test first. So I'm going to run an integrated site test, which it'll go through. It'll test the, now since we have PTs involved, we're going to run a test on, we'll do a customer load test on the meter. We're going to do we're going to test the CTs, the PTs, and then run a phantom load in that order, okay? So everything looks okay there. I don't have any double wrapping of my CTs. That would be the only thing I would change here. So I'm not doing that. Also, sometimes folks change right here. They change the parameters of the time on this and how long to run the test. You know, I always like to go 30 seconds or 3 revs. But those would be the only 2 things you would change at this point because you've already pre-entered all of that integrated site test. You might change the time parameters, or you might add that you've double wrapped your CTs, your red flexes. So we're going to go ahead and hit next. And there's that wiring diagram we were talking about. So you can see here the difference we talked about. Now I don't have 3 voltages, I've only got 2. So we're going to sum, well, we'll get to that in a second. It causes us to have to sum the currents on here because we've only got 2 voltages. So we'll see that here in a second. So let's go ahead and run a normal test here. So I'm going to go ahead and hit next. Now remember, I'm just going ahead and running through this test because I'm kind of cheating here a little bit actually. I know that it's a normal setup, so I know there's nothing wrong here. But if I were out in the field at a site that I didn't know if there was a problem or not, I would start in by looking at my vectors first before I start the test. Because as we've preached and talked about in so many of these webinars, it gives me the ability to toggle right between some of these different buttons on the kit and utilize some of the features it has that aren't available once you're into a test sequence. So what I would do here is I would say and I'll do it when we start going into these error scenarios Mullen's going to sling at me. I first would start out by just looking at the vectors and looking at the power chart. That way I can toggle back and forth between my primary, and now because we've got this non-Blondel funkiness here, I can also toggle between my meter connect, which is what the meter sees, versus the actual power and how the designations are on the power, okay? Where we're summing some of the variables here, which in this case we're going to have to sum our current. So here it's showing me my vector. So I'm going to hit continue. And notice here, these currents, it says I got secondary voltage C phase, secondary voltage A phase, but notice it says secondary current AB and secondary current CB. So you can see it's summing, right? Because normally it would just say secondary current B and secondary current A and secondary current C. But when you see more than one on there, you know there's something going on, and in this case we're summing it. Okay, so that's why you're seeing more than one phase designated on one vector would indicate to you that you're summing. Okay, so we will go ahead and hit continuar. And wouldn't you say, Chris, that typically, especially when we're dealing with something like this, non-Blondel, where we're summing now, and we're only having 2 instead of 3, you know, we don't have 3 separate values voltage, 3 separate values current, that if you have a problem, that typically you'll get hung up on trying to get a pulse, because it's going to tend to knock down your watts so much that it's going to be difficult to get a pulse. You'll either wait forever or you might never get one. That's another one of the reasons why we go ahead and start out with just looking at just the vectors and just the power table before we go into a test. That makes sense? Okay. Chris is nodding, by the way. We should put a camera on Chris. Okay, so the meter test came out okay. So I can tell you with a 6S Z coil, then that means there's nothing messed up. It does not take much to be wrong with a 6S Z coil that you're going to have a tough time getting some pulses, okay, and running that meter test. So right now, everything looks cool. So we're going to go ahead and go to our next test. Because if I have 3 phases and I'm reading 3 phases, if I have an issue on a couple of them, I'll still have something there so that I'll be able to test. But now, since when you start deleting and you start minimizing the number of 3 voltages and 3 currents, either by going only with 2 CTs or 2 PTs, the problems seem to cause you to not get pulses and cause the problems to be more drastic as far as trying to test. Okay? So here's our diagram with a little funkiness right there again. So I'm going to hit next. So now, since I have 3 CTs, I will get 3 CT tests. Okay? Two, come on. Come on, 7. One time. All 3 passed. So we got our green passes. So all 3 CTs tested out okay. So now we are going to go to the PTs. But remember now, we only have 2 PTs because we only have 2 voltages. So we will just be testing A and C phases on the PTs, okay? It always, as we've said before, it always shows you the wiring diagram beforehand. So we got a pass on both of those. These are 2.5 to 1s. So that came out pretty well. So we'll get to our last one, which is the phantom load test. So let's put our jumpers on. As we've talked about before, you come in here on the bottom of your return or your long stroke switch here. So you have to get around those handles at the bottom. So we come up over here at the top. We go A phase to A phase, orange handle on this test switch. And we also go, here's B phase, blue to blue, bottom of the return, top of the shunt. So it provides the current going right into the meter out of the top of the shunt blade. And then here is the black and the white switch over here, the black and the white switch. Is anybody saying anything in the chat room yet? They're going, wait, John. Nobody. I didn't open up my shunt blades. I got to open these up, right? Now, if I didn't, what would happen is it would say, I almost ran the test just to see if anybody would say anything. If you run the test, it would say unexpected current. Okay, so it's because it's expecting not to get any current from the CTs to perform this test, right? I'm providing all the current. So you would say it's going to see unexpected in there. So then you would say, oops, I forgot to open them up. All right? So we open those up. And so now I'm providing the current, so I'm hitting up at the top of this switch. I'm coming from here, jumping up the top, and I'm going to that meter and then coming back through the duct bill again back to my test switch. Okay? Cool. So let's run the test. So it's going to go through all the checks like it always does. We have a few more checks now between a customer load test and a phantom load test because there's a load box involved. So as we always say, we want to be a little bit safer when we're dealing with the load box. So we run through some more diagnostic checks internally and just make sure everything's okay. Send out a little VA and make sure we don't have either a loose connection or some broken connection in there so that I'm getting too much resistance there. So if it likes everything, it's going to go ahead and give me the large pulse will light up and give me the tone and let me know I can start the test. And because the professor taught me that way in the beginning, I always let it go 2, so there's 2. So we'll start the test now. Full load power factor light load test. Did you set up 3, 3, and 1? Good. That should be 3, 3, 1. Cool. And in case you didn't see a previous webinar while this is running, to perform the PT test that we did earlier, we're using our VP600 right here, which is rated for 600 volts or less. If it was high voltage stuff, if you're a sub or anything, you would use the high voltage probe that's mounted on the end of an extendo stick, up there. So these numbers are falling within the range that you set your test kit up for that said would be pass or fail. As long as it falls within that, we get a green number. It tells us everything's okay. So far so good for the full load and the power factor test. And then the slow light load test is the last one. I will say that I enjoyed it this morning for the first time in a long time. It was a tiny bit cool this morning. It wasn't cold, but it was a little bit cooler than it's been for a while, so I'm hoping. But it usually teases us here in Knoxville. They'll act like it's going to start cooling off, and it'll get scorching again. But it wasn't as hot lately. Even my guys up in New York are telling me they're scorching up there in New York. So I think everybody's burning up right now. Yeah, I was talking about you, Matt Perry. Oh, no, I made it 111. Good. It was a quick one. Yeah, nice. I believe so. This one's 111 on the 5A quick. Come on, 7. Yes, sir. All right, so we got pass, pass, and pass on the full load, the power factor, and the light load test. So we will hit done. And as you know, we've talked about this before, but just in case you haven't seen this before, when we complete this, it goes back out to the menu, and I'll show you here that you could recall your data and take a look at what you just did. So if I hit number 7 for recall data, I could just pull up 6S site right there, and I hit expand because it's just a tree diagram here, so you just expand out. And this is the test session for today. We started it there when Mullen set her up. So we'll go there. And we'll hit expand. It shows you all of the tests that we've been running, okay? So we could go to any of those and take a look at them and say, because we were running a bunch before you guys got here. So you could just pull any of those up. The latest is always at the top. So we could hit here, hit select. There you go. So you can always recall it. I recommend that you do before you disconnect everything, just in case you didn't fat finger something or skip something or whatever. You would just want to make sure the test kit had captured the work that you've done. You don't have to go back. So I just recommend you take a quick peek. It doesn't take but a second, and then you can disconnect and go to the next one. All right? So I'm going to previous out, go back to here, and I will let Chris Mullins start throwing the curveballs. As a pitcher, his fastballs aren't that great, but he's got some pretty good curveballs, I'll just tell you. You can snap them off at the end. So I've got my PPE on. So I'm going to go ahead and start her up. It's telling me it's stabilizing, so I'll just wait, make sure I don't get in too big a hurry. Let it stabilize first before I can start. Okay, active looks good, so we're ready to start. All right, so as we said before you get going, go ahead and hit your vectors in your power table and see if you see any clues or any problems might be going on. Okay, so let's go ahead and do that. So I'm going to hit the vector button. Okay, we saw our vector button earlier, and it definitely didn't look like this, right? We saw our vectors earlier, rather, going through the integrated site test. So we know it definitely didn't look like this. So I can go to, I've got some selections here at the bottom that I remember I don't have if I'm in a test sequence. So this is why you hit in the beginning and you start this way. Okay? So I'm going to go ahead and I'm going to hit, oh, wait a minute. Now, they both had fun with me, right? Remember with that? So if you could have just seen Chris Mullins' head jerking around looking on his monitor. He kept looking over the bench and looking at his monitor, looking at the bench, looking at his monitor. Something's not right, something's not right. And there you go, and I'm not done yet. Payback is a son of a gun. But anyway, okay. So if we look at this, we can see this is definitely not what we saw earlier when we were running through that customer load test. Because remember, it always shows us the vectors. So let's start looking at some things. So we've got the reference button here so we can reference what it would look like, it should look like. Okay, so let's look at this first. We'll go to the reference button. Oop. I'm going to go to Connect View. So you saw, I looked at the reference button, and the reference button looked just like the one that we saw when we were doing our customer load test. But this is the Connect View. So this is actually the connections that we've made versus the actual power, because remember the meter is measuring power. So what the meter is saying, because the meter is having to sum. But in this case, look, we're seeing our, because that's how I actually connected it, right? I've got a duct bill in there for my B phase, right? So what's going on? Well, if we look here, this is my A phase voltage. Everything on the test kit, that's what it's established off of, is that A phase voltage, okay? That's our reference that we go off of. So when there is a problem, everything can mirror image or spin or rotate off of that. And if you look at this B phase right here, my B phase current, I know from having seen so many of these vectors, it should be down here. So what's happened is I can already tell it's flipped it or rotated it around, okay? Then I can look at this as well, and it looks like I've got polarity reversal on A phase, okay? So I know just by looking at that already I've got an issue. Now let's go ahead and go over here to meter view. So the meter view is where it's doing the summing, okay? This is where we should see the summations going on, because you can see now where it's saying secondary current, CB, and secondary current AB. On the other, it showed all of my 3 currents separate because I do have 3 separate ductbills in there. So I already know that I have a problem. And I'm going to go ahead and hit my power button as well over here. So I can see here, I hit my power button. Okay, let's go into a test then. Let's try this. Let's do a meter test. A customer load test, 1. We can see it this way. Now, so you can see it. There we go. So if I look at this, I can see that I don't even have enough watts right there to run a test, right? So what's going to happen is if I try and run a test, I'm going to be sitting there all day waiting for a pulse, okay? And that's why you should take a look at you should always take a look at the vectors pre-test. You should always take a look at that power table pre-test. So I know now that there's some problem that's causing, I'm not getting even enough. These two are canceling one another out. So I'm not getting enough right here that I can even really test the meter because I'm not going to get any pulses through it. Okay? So going back to the vectors again. Well, my hot buttons are not wanting to play nice this morning. We will actually demonstrate by showing you're not going to get a pulse. So we can just sit here and wait, and we won't get a pulse. Because you saw how many watts it was. Okay? So we'll previous out of that. There's no use sitting here waiting because we know we're not going to get one. So all the way back out to here. But let's go ahead and test the PTs. Okay, so we're going to do a PT test. So I'm going to go number 4. And I'm going to do a PT test here, number 3. I'm going to go ahead and start test. And we'll hit next. Okay, now wait a minute. How am I getting a pass on these two? How many times have we said that the secondary follows the primary? So now let's think about this. If I do all of this, here's what's going on in my P-brain and using my eyes and looking at the equipment. I know that my A-phase voltage is my reference. It looks like things have rotated and mirror-like around that, okay? So it looks like I've obviously got something, polarity-wise, I've got a problem. Okay, I'm doing the test, and it's saying that it's giving me a pass on the 2 PTs. So that would tell me then, remember, if it follows, if I have a problem polarity-wise on the primary, then it's going to follow on the secondary, so I'll have a polarity problem there as well. So what happens is, it's looking for 2 things. It's looking for amplitude and polarity. It's making a comparison there, right? Amplitude-wise, it's right on the money. It's supposed to be 2.5. Yeah, and it's right on the money, 2.5 and 2.49. Polarity-wise, I had the problem on the primary polarity. Well, the same problem followed down on the secondary. But those 2 polarity problems doesn't show a difference. Where it's going to show me a difference on the test is where there's a difference between my primary and my secondary. So that would mean if I have a problem on a secondary side and compare it to a proper primary, then guess what happens? Then I show polarity reversal and I start getting the errors and showing things, okay? So, since it passed that test and everything was okay, I would say that there is a problem on my A phase PT, since everything is referencing off of that. I'm going to say I've got an A phase PT problem, is what I'm saying is a problem. And obviously, since we're seeing everything's polarity, so then that's what I would say. I've got a polarity issue on my A phase PT, on my primary current. So I think I have polarity reversal on A phase. Okay? Okay. So, is that right? Okay. So I hope everybody got all of those clues told us that that's where I'm thinking my problem is. So I would go check my PT on A phase and check my connections on that PT and make sure I don't have a polarity issue on that, okay? Okay. So, let's go. Now we're going to go to the next issue. And I'm going to, let's see here. I got to start my test back up again. Okay, let's go. You ready now? Okay. Here we go. Whoa, 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 whoa. Okay, so we're ready to go. So we have got, so now it's another curveball from Mullins. So we will do what we said. If we're out there in the field, we're going to look at our vectors, and then we're going to take a look at our power table if we need to look at that. Okay, so we're going to start with our vectors. I'm going to sound like that Olympics gymnastic coach. You can do it. Come on. All right, let's start into a test then. We can look at the vectors by looking at a test. Okay, we should see our vectors now. My hot buttons don't want to play nice this morning. We'll find another way around. Typical field, right? Okay. So we can see here that we have, it looks like I've got polarity reversal on both of the phases there. Okay? So it looks like I have, because we know that when we have between our vector for our voltage and our vector for our current, and they're about 180 degrees out, we know we have polarity reversal. Well, I've got it on both A and C phases, both on my red and my blue. So I'm thinking that I've got polarity reversal on both phases here. And what would we think would happen if we have polarity on both of them? We'll take a look here in a second and see. I'm getting a pulse. That makes sense to everybody? So in essence, I have polarity reversal on both phases, so therefore everything's negative, right? So this would be similar, it looks what you would look at a solar farm or something, because now everything's flowing in the wrong direction for me when I'm trying to test this. So it would be, like I said, just like a solar farm where you're getting received instead of delivered. So my registration is negative right here because I have polarity reversal on both phases. If we take a look over here, our power table, that shows us negative watts and negative watts. Negative watt hours, right? So I end up with negative watts. So since I have the negative watts, so looking at the power factors both being negative here, a negative power factor is always a result of polarity reversal. So I see negative power factor, so that tells me polarity reversal, and then my watts being negative for a total, negative for negative total is also showing me polarity reversal. Okay, so to me that's showing that I have polarity reversal on all the way around. That makes sense to everybody? Cool. Okay. So we will run a CT test. So I'm going to go 4. CT test, number 1. We're not double wrapping anything, so we'll just keep going. So remember, 2 PTs but 3 CTs. So we will get all 3 CTs tested. Just as we suspected from earlier, right? From looking at our power table, that was telling us what this, we kind of knew what was going to happen, right? Because we saw negative power factor, and ending up with a total of negative watts. So we ended up with a negative registration. So we would expect to get polarity reversal. Here we go. So it is polarity reversal. So all 3 of my CTs have polarity reversal on them so far. So we'll look and see. Because remember, we had what we were showing before was a summation of the 2 currents. So this will actually show us all 3 phases that actually all 3 phases have polarity reversal on them. On the power table, it was showing the 2 summation values, right? So you only showed 2, but here it's showing literally all 3 individually, and all 3 of them fail, fail, fail. Follow the red as we said a million times, and we've got 180 out, 180 out, 180 out. So that would be indicative of polarity reversal on all 3 of my CTs, okay? A, B, and C phases, all right? So even when the machine's acting a little funny with you, there's still ways to look at everything, right? My hot button wasn't working right, so I just shifted over because I knew I could see my vectors when I ran my customer load test. So I just went into my customer load test, I saw my vectors, then off of that, once I saw my vectors, I hit the button and toggled over and took a look at my RMS table then. When I looked at it, it showed out what I was saying, which I got both of the summated values, both came out to be negative, so that means that I had polarity reversal on all. And then when I ran the CT test, it showed polarity reversal, polarity reversal, polarity reversal. So I know all 3 of my CTs had polarity reversal on them. Therefore, I'm going to end up with negative watts, so I'm going to end up with negative registration. Okay? I'm going to do the, just the PTs or the last one? On that one? Go to the last one? Okay. So final curveball from Chris. So let's see if I'll give it a shot, but it wasn't playing nice earlier. Ah. Okay. So I'm going to turn it on and start it. She's going to jump around until it stabilizes, and because this is what you see when you're out there and you don't have any load, right? It's just running around. So until we get there, we go. So now it should be stabilizing here in a second, and it should say active. There it is. So active. Okay. So here, how does everything look? Doesn't look that bad. This is pre-test, right? So I've got those buttons again now. So I'm going to go ahead and hit the reference button. Looks good. So my vectors are looking good so far. All right, so no problem with my vectors. Remember with the connect view, which I think is pretty cool, the actual connect view is showing how you connect to perform the test. So I do connect my duckbill on B-face to run the test because I have 3 CTs, okay? So one is showing the meter, which is measuring the power where it has to sum those two currents. This is actually showing the way you connect it, okay? So we'll go back to meter view. So that looks okay. That looks okay. I don't see anything squirrely there. So let's go and let's try a test. So we will just run. What do you want to test, Mullins? Okay, meter test and CT test. So first we'll do a meter test. So we will go 3. We'll do a customer load test. 1. All that looks okay. So let's go next. Everything looks okay. We believe we have it connected correctly. We got a pulse. Let's wait for that second one. Good looking number. You can live with that. Oh, test complete. So we are going to get done. Now we'll go ahead and test CTs. So we'll go previous. We will go number 4 for testing PTs and CTs only. Not the full-blown integrated site test that we ran in the beginning with the normal test. So we will go to customer load test on the CTs. Just hit enter. So now it'll test A, B, and C phases because we have the 3 CTs on there. So hit start. We're not double wrapping anything. And we have entered in, notice there, we've entered in the actual CTs and PTs. You don't have to enter them in there. Remember, if you've had me at your place and we've done the training, you can just fill out that top part when you create a site, which that's all you're required. The site, the service, then some unique name for the site, a service type, the meter form, and then which kind of a test you want to do on it, your integrated site test, and then the K sub T. And that's all that's above, on the top half of that screen to set a site up. And then once you do that, you can start testing. You don't have to put any information about the CTs and PTs. The machine will work that out when it does an actual measured ratio versus the nameplate ratio. Okay? The reason I mention that, I don't know if you noticed, but usually when I'm running these tests, you don't see all that information in there down there about the CTs. But all of the information was in there down there because we did enter in information on the PTs and the CTs. We picked one out and attached it to this site. So does anybody see why we failed C phase? It's got a ratio error of 100%, so it's 100% off. Well, if I'm looking at this, I notice 200 to 5, 200 to 5, right? But then the nameplate ratio 200 to 5 because I entered it in. I put that in there, 200 to 5. Okay? So it's looking for a 200 to 5 ratio on all of those. But what happened was Mullins put in there where someone grabbed the wrong CT off the rack, or it was a mislabeled CT, or you got storms and the linemen are trying to get out there and get everybody's lights back up and running, and somehow they grab the wrong one out of the 3 and slap them up there. So now I have got the wrong CT here on C phase. I've got a 400 to 5 instead of a 200 to 5 on C phase. Now remember what I said in the beginning. This is really important. If I hadn't entered anything in there, it would have given me a pass. Okay, it would have said a pass right there. But instead, because I entered it in and put the specific information on the site of that CT, it's telling me it's looking for a 200 to 5. So you got to watch that. I was doing some training up there in Indiana this past week, and I didn't enter in the information about the CTs on purpose. So it said pass, 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 but one of them was a 400. So you got to look at that and notice that, okay? But what it's trying to tell you is, hey, if you enter it in there, you'll get the fail. But if you don't enter it in there, as long as the ratio is good, okay, between the 400 to 5 and what you measure there, it's going to say okay. All right? So you got to remember, you're going to have, if you have a failure there, look for that because there's a different size right there, okay? So that different size on that is telling me someone has grabbed a 400 on C phase. All right? So I'm going to hit done here. And that's telling me that I somehow grabbed the wrong CT again, or it's a mislabeled CT. We've seen them out there in the field. I mean, all 3 of them. I mean, all of the CTs up there, on one side of it, it had a plate on there, obviously, that had correct, and then they were sitting there labeled right on the outside wrong. 800, 800, 800, right on the side of them. They've been painted on the side of them, but that wasn't what it said on the nameplate. So you'll run into it. It actually does happen. And I know there's people out there probably nodding their head going, yeah, I've seen that before. It's not often. Typically someone is going to grab the wrong one. The mislabeled ones do happen though. I've seen them out there where if you look at the nameplate, they're 400s, but they're right there painted on the side, 800, 800, 800. All right? So hopefully we've learned something about the 6S coil today. We've learned that since I don't have all 3 of my voltages, I'm doing a summation there, so my vectors do look different. So what I have to do is I have to make sure that I use, if I can, the toggling of pre-test to toggle stuff, okay? So when I do that, it allows me to toggle so I can take a look not only at the connect view, which is important, how it's actually connected versus what the meter's seeing. And that's when what the meter sees is where you'll see the summation because it'll label those voltages or currents. It'll have two phases on each one instead of one. So instead of just saying IA, it'll say IAB, and it'll say IBC. That means it's summing those currents, all right? So it's using B as a reference there. So that's so you can use those different buttons there, and also, as we said before, you can check primary versus secondary. So if you toggle over in the primary and the secondary both look the same, then I know the problem's on my primary side. Secondary always follows the primary, so that's why I could get a good ratio test. If I just went out there and did a ratio test, if both polarities are wrong, it's going to be okay with that as long as my ratio is okay, as long as the amplitude's okay on the test. All right? So we're not going to have a webinar on Thursday, but we will definitely start back up next week. So be on the lookout for what we're going to talk about next week. I hope you guys have learned something on the 6S today. And if you have any questions, please let us know. We just really appreciate the support, you guys tuning in to us. And remember, these are all on YouTube and on the on our website. And Jarrett records all these and puts them out there. He edits them a little bit and gets some of my goofy stuff off of there. And then he puts them on there so that you can look at them at any time. We know the guys that really need to be seeing this right now, COVID doesn't affect them that much, so they're out there working. You guys are wide open out there testing out there in the field, okay? So because it's real easy when you're up in a bucket truck to get social distancing, right? So so you're still doing your testing. So if you have a chance, look at them later, either on the website, like I said, or on YouTube, all right? we really appreciate you guys. If you have any questions or anything, like I said, holler at us. No, that wasn't my email. Okay, so you're not ignoring me, I hope. Anyway, see y'all later. Thanks a lot. God bless y'all. Be careful out there.